Hello, welcome again. We are solving some questions of machine design. The topic is friction in screw, bearing and clutches. Question number 19 and 20 carries a common statement. The statement is a torque of 350 Newton meter is transmitted through a cone clutch having a mean diameter of 300 mm and a semi-cone angle of 15 degrees. The maximum normal pressure at mean radius is 150 kN per meter square. Coefficient of friction is 0.3. Question number 19. Width of the conical surface. Option A 55 mm. Option B 60 mm. Option C 51 mm. Option D 45 mm. Question number 20 is if the clutch is disengaged by applying axial force on the spring of stiffness 200 Newton per mm, then the deflection of the spring is approximately option A 12 mm, option B 10.06 mm, and option C 8 mm, and option D 15 mm. So here the given data are torque to be transmitted is given as 350 Newton meter, and the mean diameter is given as 300 mm. So mean radius is here 0.15 meter. Mean pressure is the pressure maximum normal pressure at mean radius is just 150 kilonewton per meter square, and coefficient of friction is given as 0.3, and semi-cone angle is given as 50 degrees. So this is your semi-cone angle. Okay, so this is your semi-cone angle is your 50 degrees. And now in case of clutch, the general formula for torque transmitted is your mu Fn Rn. So mu is your coefficient of friction, Fn is your normal force, and Rm is your mean radius. And the torque transmitted is given as 350, mu is given as 0.3, and mean radius is given as 0.15. So from this we can calculate Fn is your 7778 Newton. So this is your 7778 Newton. Okay, and this force is acting perpendicular to the surface. So if as mean radius is given, okay, and the maximum pressure at mean radius is given, so the area for this pressure or for this force will be 2 pi Rm, because inner and outer radius are not given, so we will calculate like this. This is small as compared to R naught and Ri, so we can calculate circumference and then multiplied by width. So it will be 2 pi Rm into B. Okay, so Fn is your 2 pi Rm Pm into B. So Pm is your 150 into 10 power 3, Rm is 0.15, and B is your Fn is your 7778 Newton, and B is your 0.055 meter, or it comes out as 55 mm. So the width of the contact surface is 55 mm. Answer to question number 19 is A. Now we have to calculate the deflection of the spring if the stiffness of the spring is 200 Newton per mm and axial force is applied to disengage the clutch. So now we have to calculate this axial force, the amount of axial force which will remove this normal force from the clutch. Okay, so as this force is acting in this direction, so its component in this direction will be your Fn sin alpha. How? So this angle is your alpha, this angle is alpha. So this surface is perpendicular to this, and this surface is perpendicular to F. So that angle will be 90 minus alpha, or it will be so F will be Fn cos 90 minus alpha or Fn sin alpha. Okay. So this will be your Fn sin alpha. So that is your axial force. So axial force is 2012.4 Newton. So that is the force which can exert an opposite force equal to in the clutch. Okay. So as the clutch is disengaging, so there will be displacement of spring, because spring is also because the force is applied against it, spring which during engagement makes contact between two friction plates. So when the clutch is pressed, the contact has been removed, and this disengagement of the clutch takes place, and the contact has been the clutch is pressed by this force Okay, so this force is in axial direction. Spring is also in axial direction. Okay, so this force will be in this direction and spring will be also in axial direction. So it will remove the the plates from the remove the contact of the plates. Okay, so app will be your as app is your 2012.4 Newton. So the axial displacement of the spring will be your axial force by spring stiffness. So as spring stiffness is given as 200 Newton per mm, so the axial displacement of spring is axial force by stiffness, that is 10.06 mm. So answer is option B.